Welcome to the maker's world, where every spark of an idea becomes something real. Right here in Czechia, we build tools that peer into particles and launch satellites into orbit. It's where the word robot was born. And Čapek's vision of automation still fuels the imagination of today's inventors. From prototypes shaped at Fab Labs to bold experiments led by students, entrepreneurs, and researchers. This is curiosity in motion. The next era begins with you, innovating, exploring, going further. From clean energy to quantum breakthroughs, we're shaping what comes next. Over the next 8 days, FabX comes to life. 42 speakers, 255 sessions, 100 chances to get hands-on, 5 evenings of conversations that matter, and 6 mobile Fab Labs, arriving ready to build, share, and inspire. From every corner of the world, you're coming to be part of it. This isn't just an event. It's a celebration of making, sharing, and shaping what comes next.
Good morning, everyone. Hello, dobré ráno, as we say in Czech. Welcome to FAB25, Day 7. I hope you had a lovely time yesterday. You explored Prague, had some conversations, forged new friendships, and enjoyed the program. Today, we have a very exciting day ahead of us. I hope you're excited, and it's a pleasure for me to be your host. My name is Falk, and I work as Josef Prusa's stunt double. And yes, there are moments he needs one. Today, more importantly, today is Prusa Day. And for us, Prusa Day is more than just a showcase of technology. Today is about a shared vision. The same as Fab Lab. We believe in making means to make, to create, to invent, to give the technology, to make it accessible to anyone who wants to create or invent something. And we value community, and we were born out of the community. So we believe in shared vision, shared ideas, and forging better tools for tomorrow together. That's why being a general partner for FAB25 was kind of an obvious thing, no-brainer, because it's incredible for us that such an event takes place here in the Czech Republic, in Prague, in Brno, and just a year before it returns to Boston. We're here, and for 7 days, Czech Republic became officially the maker's capital of the world. That's so incredible. So we look even more forward to what we're able to do with Fab Lab together in the very near future, because we're looking for means of how we can support your projects, your inventions, to find ways for how to make it even better for you. So great times lie ahead of us. And today is dedicated to showcase 3D printing and how it can help your projects, your Fab Lab, any kind of way, any kind of industry. And for that, we brought in so many cool people, experts, influencers, my colleagues, all of us, for keynotes, dive-ins, hands-ons, you name it. We got it, we prepared it, and we're ready to share our know-how. You can also visit our factory, see where the magic happens, and it's just behind the corner. And as is customary in Czech Republic, there's going to be a party. A Prusa Day has to end with a Prusa party, right? So, yeah. Looking forward to that. Yeah. So, shall we get started? Yes? 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 Sadly, we can't. Those evil guys who organized this thing made me swear that before we start, I'll share some practical information. Then we'll get start. Okay, so it's gonna be short, right? First point, the layout of the day, same as yesterday. Morning program, afternoon program, in between lunch, then the program in the pavilions. One and only rule, no food, no drinks, and no bags and laptops here in the auditorium. Please, leave the bags in the cloakroom. Good thing, there's going to be a Prusa zone in Pavilion C. There's a Prusa zone. You can come there, talk to us, share your ideas, just chat, ask, anything. And, this is the great one, there are Prusa deals prepared. Check your bags, and there are some incredible discounts for both machines and materials. In fact, those are discounts we have never given before. So please explore them, please enjoy them, and I would like to invite you to setting up 3D printing business in Fab Lab, expert talk that takes place in the Pavilion C at 5 o'clock, where you can learn more about how we plan to support Fab Labs, support your project, and how many things we came up with. So on that note, let me invite you to some special talks and seminars. I would visit if I had time, because I'm going to be doing my own seminars, I can't, but let me invite you to the Prusa Caster Experience, which is held by Mickey. I think you all know Mickey, and Mickey will tell you how to build a 3D printed electric guitar and how to really rock. And you'll know why his name is Mickey the Rocker. If you're wondering on how to make your 3D prints look believable, on how to give them that extra touch, I recommend you visit the post-processing of 3D prints, which is held by our very own David Schwartz, aka the Prusa guy, aka Tattooed Hands. You saw his hands in most of our videos. And what I look forward, and I will have to make time, is a talk of adapting 3D printing in a game development studio, and that's held by Larian Studios. So after taking over the gaming world with Baldur's Gate 3, they're gonna do something cool with 3D printers. Looking forward to that. And my last recommendation is to visit our dear friends 3D Sets seminar. It's called 3D Printing for Business, and it's a story about how a hobby became a worldwide successful business thanks to 3D printing. Yeah, that's all. Wasn't that bad, right? So, once again, let's try it. Are you ready for the real stuff? Can we start? Yes? Yes, perfect. Yes. So, since all of you are here, since this is such a huge event, it would be like a real shame not to announce something, right? So, get ready for an announcement. I would like to invite to the stage Mr. Suchit Jain, the Vice President of Strategy of SolidWorks, to make something announced.
Good morning. How's everybody doing? Yeah, after hopefully a dance night. I was personally dancing myself yesterday. So I want to talk a little bit about opportunity, the time we are in right now. And I think all of you would agree that the opportunity to change the world is here and it's not more urgent than any time else, and all the tools and the technology available are here for us. So in 1965, some of you would maybe recognize this. This is one of the first mini computers, PDP-8, by Digital Equipment Corporation, right? So it was approximately the size bigger than a refrigerator, right? And then nearly 50 years later, you got the Apple Watch. Anybody wearing Apple Watch here? Yes? Well, I see one there. So now that Apple Watch in 50 years, packs more power, much more, exponentially bigger power than that PDP-8. These two gentlemen, Hideo Kadoma and Charles Hull, Hideo Kadoma created STL, the stereolithography as we know it in 1980, 81. And Charles Hull, around the same time, created rapid prototyping, and now what we know as 3D printing. And if you look at maybe 25, 30 years later, the technology, again, exponentially, from 50 years, if you go back from the first flight with Wright brothers, it took 200 years to go to space. I just talked about the computers. In 50 years, you got to more compute power on your wrist. And in 3D printing, it's also the same thing. In less than 20 years, people are printing live cells. So CellLink is a company which is printing live cells so you can experiment with it. Nano Dimensions has been doing electronic ink. A lot of other companies has been doing. And of course, who would not love to 3D print food? Has anybody tried 3D printed food ever? No? Oh, there's one up there. Well, I haven't done it myself. How was it? Bad. So, but the technology is just, the point I'm making here is about the exponential. We are living in a lifetime where time is compressing, technology is moving faster. Of course, the point about accessibility is very important as well, right? Exponential technologies are exponential because of the accessibility they provide. I think all of us would remember ChatGPT and AI. The talks have been there forever, but ChatGPT, I believe it was November 2022, and look at it now, right? Everybody is talking about AI and the exponential leap in just few years, what it has made. So we are living in this beautiful world of technology where accessibility and exponential growth is happening in IoT and robotics. You've seen electrical vehicles. Just in last 5 years, the autonomous cars are just working beautifully on the roads. AI, all of these things are making a lot of things possible for you guys, right? Everybody here, right? You guys are all makers making things. All of this is available to you guys, right, to make use of it. Let me a little bit talk about us as in Dassault Systems, what we do, right? So we are around 25,000 people. A majority of it is engineers. I'd say 60% of us are engineers, and we have a similar vision. Just Dassault Systems started in 1980s of this idea of providing 3D design capabilities to everybody. We went into sort of product lifecycle management, and I bet you that every one of you who has either traveled here by plane or by a car, you probably experienced our technology because all of those things are designed with the help of our software. And our goal really is to empower every one of you to innovate, right? So we are a tool set. We are not the ones who are creating these innovations. You are, but our goal is to provide all the capabilities to do so and in a very easy way. We operate in pretty much all different countries, including of course, here in Czech Republic. And we have over 4,000 clients across the world. I work more closely to one of the brands called SolidWorks. I'm sure a lot of you are very familiar with it, probably are using it. We have over 8 million users. A lot of students as well using it. Of course, is predominantly used in the industry as well. And, so whether it's a plane, car, your home electronics, chairs, furniture, hospital beds, medical equipment, this is what the tool set industrial companies are using to design and create and manufacture the tool set. And if you look on this slide, you will see we talk about this virtuous cycle of innovation happens at every age. Earlier in my train, I met Sophia when we were coming down. Sherry, you might remember I was sitting across Sophia, who's an 8-year-old Polish girl who's attending the Fab. And if you talk with her, she'll tell you. I mean, she speaks English pretty well for an 8-year-old Polish girl. And I was talking with her mom, and she's learning English through Duolingo and things like that. But was very energetic and trying to make things. So we have, starting from all the way from, say, 8 years old or even younger, all the way to whatever, right? I mean, everybody's a kid making things at the end. So we want to make sure that everybody has the power to innovate, whether it's the students, whether it's an entrepreneur, whether it's a startup trying to create something, or, of course, if you are working for a company. As I mentioned, the community of SolidWorks is very large, and we work with a lot of startups. Of course, with the Fab Labs, our relationship with the Fab Labs started in 2014 or slightly earlier. You see a picture up here in Rwanda, which we are very proud of. We had a lot of hands-on experience with Neil teaching us some making during the Fab in Kigali when we were up there, so it was a lot of fun doing that. And we made a decision at that time that we want to be associated with the Fab Foundation in a big way. And then we committed that we will create a Fab Lab every year in some part of the world. We're essentially working with MIT and CBA, Sherry, Neil, and the team who will provide the help and the know-how to create it. We will create the funding and the network as well to do it. So we started with Rwanda. We are proud to have one in Nepal, proud to have one in Bhutan, proud to have sponsored one in Chile in the southernmost part of the world. And of course, we've been working very closely on this idea of how can we replicate, instead of doing 4 or 5 of these, can we have a bigger footprint of accessibility? And this is why we are talking about Fab in a Box, and I think you guys have seen it, so this is something we are very passionate about, and working with Foundation to really sort of take that making technology and make it accessible to a lot of people. And of course, it's not just about the machines and the tools, it's also about the curriculum and all of those things, the know-how, if you will. So we are packing that in there as well. Of course, we are also working with Fab Academy, which I know a lot of you guys are there. I put this up because we also sponsor students who are working on Fab Academy. We also have our own Fab Lab on our Waltham, Boston campus. And next year when the Fab event, the FAB25 will be in Boston, I think just like the Průša Day today, we should have a SolidWorks Day on our campus, and we'll hopefully have a lot of you guys attending that and seeing what we do out there. Okay, this is an example of one of the makers who went through Fab Academy, Jose, and now he has his own startup. As you can see, he's proudly using the Průša printer. I don't remember, Abhishek, how many years was it ago? 6 years ago he started, and now he has a pretty good company in biomaterials doing packaging materials there. So we had a great relationship with Jose. He's a great guy. Okay, so we are here on Průša Day, so I got to talk about what we are doing with Průša as well. So we, of course, love what Průša represents. Access, I talked about that, exponential technology do not become exponential unless the accessibility is lowered and the humans are involved in it. So accessibility, the community, and the innovation which they bring from Prague, or should I say Prague, to the world, right? So that's what it represents. And our relationship with Průša is getting closer now, but it's something which has been going on in different ways through the community, through the grassroots, if you will. So Carlos Reyes is here somewhere. Is he here right now? No? He probably will be, well, he is here, but he's presenting later today, who's an influencer and also does a lot of, he's a maker himself, does a lot of stuff. He's a French Mexican maker, and he does a lot of very interesting videos. So if you get a chance, talk about it. Go watch it. He uses SolidWorks, but of course he uses Prusa for 3D printing, a lot of the stuff he talks about and makes. Here's another little video of what he's doing. Okay, so I think, as I mentioned, we're starting, as this event was being put together, we started to talk with Prusa a little bit more, and you will see in future more announcements coming on how SolidWorks and Prusa can work together. They are working currently on becoming part of a solution partner program where if you're designing in SolidWorks, you can directly send stuff. It's sort of custom made, if you will, for Prusa printers. You can directly print there without having to do so much of work around. And then also we are thinking of some more creative ways in bringing kind of both of the technologies together in a big way. And I will just quickly say that for overall, starting from now, anybody who buys, who's looking for a Prusa printer, we will basically have a 30% off. Our maker license, to tell you frankly, is pretty cheap. This is the same commercial license which is used to make Boeing planes and everything else, is being presented to makers for like $50 or something like that. It's relatively cheap, but we want to go even further on that. And so, yeah, so anybody who later on decides they can get this. And I might remind you, for people who are in Brno, and I don't have the QR code up here, but everybody who's attending the conference, we have also made the SolidWorks for Maker license available for free. I do not have the QR code, so either catch me or Abhishek here later, and we can give you that QR code, and you can get access to SolidWorks for makers at no cost today, if you will. So that's it. I want to just quickly close by, I started the talk by talking about exponential technology. And exponential technology, we are in an amazing, amazing time we are all living in, right? It's becoming easier, but accessibility is something which really makes the exponential technologies exponentially adaptable. We have seen what has happened with ChatGPT and API, and the stuff what Prusa is doing with their printers becoming accessible to everybody is what will take the trajectory of 3D printing. I mean, we already saw the live cells and electronic ink and food being printed, and I just cannot wait to see what more else you guys will do with it. So thank you.
The thing with the rotating stage is when you have to either run around or just risk it and look like an idiot, so like me right now. But thank you, Suchit, for your presentation. We're so excited about our partnership, and I certainly hope that you are all warmed up, because right now it's time you hear from the man of the hour, the man who started it all, Mr. Prusa, and there's a twist. This won't just be a keynote. You will also get to ask him questions. So if you run your Eventi app, there's his talk, and you can post your questions right there. We'll do a Q&A right after the keynote, and who knows, maybe your questions will get answered. So let me invite to the stage a man who wanted to be a DJ, but somehow ended up with a factory making 3D printers. Mr. Josef Prusa.
Hello, hello everyone. So first and foremost, I must say, I am part-time Stepan's stunt double. So we take care of each other in this way. And first, some organizational things. I am so sorry, my inner ear wouldn't last 5 minutes if this would be rotating. But in the middle of the talk, we agreed that we can do a 90-degree turn. And do not hesitate to shout loudly if you think I am just about to fall, because this is a new but very amazing place. So, first, my biggest thank yous to everyone who is part of this and part of the maker movement. We have some of the biggest legends who made this possible. We have Dale from Make, we have Neil from Fab Foundation, but also we have some of the biggest legends of desktop 3D printing and repair movement. We have Vic Oliver here. It is my great honor, and we finally met after all those years. And we have Alessandro Ranoluchi. He will be speaking shortly, and he laid the groundwork for the slicing software. Basically, the whole industry is using right now. Digital fabrication is incredibly important. I think it is a way how to keep manufacturing local and independent, not dependent on anywhere else. And I am extremely proud that I can support movements like this and events like this. You know, for us here in Czechia, it is not that long ago, just a couple of decades, when we had to make stuff out of necessity or to survive. And now we are extremely lucky that we can make for fun, growth, and starting great new things. And now, so who the filament is Joe? I'm Josef Prusa, and I have been making 3D printers for 16 years. I would say that was way before it was cool. And my origin story is also kind of funny. I had a good laugh when I dug out these pictures yesterday. So, I used to be a DJ. That was my main hobby. But I wanted to do a little bit more, so I started to build my own MIDI controller to control the music. And this is, I think, the best photo I have somewhere I could find. I hope this device still exists somewhere, but while I was building it, I realized I need a way to make the knobs and faders. And that is how I found out about 3D printing, and I decided to build a first wrap. But I was a little bit lazy in a way that I like to do things efficiently. So I was poking around, how can I do this a little bit easier? And in the spirit of open source, I shared it back into the wrap project. And it turned out that other people prefer the quicker way too. And because of that, it started to be possible to build the printer over a weekend. We started to do, we called it build shows. A couple of us from the Repair project, we gathered all the parts, gathered people who have been, who's been interested in building one, and we closed somewhere for a weekend, and Sunday night, the printers were alive. So that is how RepRap started. And I always get a suggestion that I should ask people questions. So I have the most important question right now. There will be a Průša party tonight, and I want to ask you, should I try DJing for a bit? Okay, well, now I'm anxious. Well, at some point, from the hobby, the time came to start a business out of it. I've been traveling the world, and everybody was asking me, "Hey, I love the design, but I want you to give me the parts. I do not have the amount of time needed." That started not that far away from here in a moldy basement. I quit the university, and my father lended me 200,000 Czech crowns, around 10,000 euros, the least amount to start a limited liability company. And I scraped the mold from the walls, got it up to the speed, and soon after I started to do the first build events together with my brother. And long story short, 12 years after, Prusa Research is now a global brand. We are having 4 manufacturing locations here in Czechia, 3 in Prague, 1 in Hradec Králové, and 1 brand new location in Delaware. We have over 90,000 square feet there. And I really, truly believe that technologies which are absolutely vital for creation of new IP, like 3D printing, because there is no engineering company which does not use 3D printing. Now, we really need to keep the capability in Europe and in the United States to manufacture these machines at volume. So I'm very excited about that. The light blue countries are the countries where we have our people. And yes. Now, how is it possible? Because over last few decades, everything has been offshore, and it seems, well, it doesn't seem. It is a harsh reality for us that some of the manufacturing capabilities were lost here in Europe and in the US. And the people who were able to do these things, they retired. And I do not think it is possible to bring all of them back. So to be able to manufacture our machines efficiently, we had to find the lowest common denominator of the technologies we can use to manufacture all around the planet. So I call this low-tech, high-tech, because our added value is about the 3D printing part, but it is not about what technology we use to make the frame of the printer. So we use basic aluminum profiles, and for our newest machine, which was really truly optimized for this, we use bench sheet metal, which is powder coated, and if we really boil it down, you can make it yourself in the garage. So you can really truly make it everywhere. But I'm super proud of my team, because I say low tech out of necessity, but you can still make nice things, and we've just recently got a stamp on that. Our core one got recently awarded by the Red Dot Design Award, so I'm very happy, and especially happy that we've been able to bring our design philosophies of ultimate repairability and lasting forever into today's day and age, and it looks nice. Our great inspiration in how we design our machines, and I know it is an urban legend, but I always have a good laugh at it. With Toyota, it's been said that they designed the machines to last for 30 years, in a third world country, so we are doing it in a similar way. You can fix the machine with a hammer and a screwdriver. And you know, when there are some Arctic expeditions, they choose Prusa. If there are some expeditions on boat, we have, I don't think I can say the name of the company, but we have a customer who has one of our machines on all of their boats, so they can send down the replacement parts as needed, or they can troubleshoot and just beam the files through satellite to the ship which needs that part, which I think is truly incredible. And I will be talking about this a little bit more later, but I really think 3D printing is absolutely vital for bringing the manufacturing closer to the place of consumption, you know, to here and United States, Americas, everywhere else. It is really democratizing. But I will go back to this point a little bit later. And I also want to say that we've been able to get to roughly 90% of the parts made around locally around Europe, and just around 10% of the parts are made in China. So that has been a huge project for quite some time. And now, as we are here at Fab Lab Foundation event, I usually do not get to, you know, speak about like our portfolio as a whole, but here it makes complete sense. Here you can see our machines, which I think together make what we do extremely, extremely efficient. We have the core one, you know, the mid-size machine, a little workhorse, which is very affordable, but it also has actively heated chamber, so it gives you options to print more advanced material just than PLA and PTG, you know, because we are making stuff which gets used mechanically. This is a huge advantage. Then we do have the XL through tool changer, where you can mix and match completely different polymers or colors, but you can make something which has living hinges out of polypropylene, but rigid body of carbon fiber reinforced polycarbonate, and the XL will stay with us for quite some time. We have some additional non-FDM tool heads coming, and that will be truly, truly amazing. Then one of the recent additions is the Průša Pro HD90. That is when you truly need some advanced materials. You know, it can print the ultimate material, the Ultim, with mid-size parts. And we also have the SLA machine for the very detailed parts. What we are seeing with our bigger engineering customers, it makes sense as a whole. For example, every engineer gets to have a core one at their table, so it supports their creativity. You know, the costs to do the prints is closing to zero. But then, after the initial prototyping phase is done, they have, you know, 1 or 2 XLs and 1 HD90, and it makes complete sense together. So I'm very, very happy about that. And now the features, I think, are truly, truly amazing. So with our Mark IVS, some months ago, we finally received the UL Green Card. Well, what is the Green Card? We are the first manufacturer who ever received this certification for a desktop 3D printer. And UL, with some other bodies, have been doing research into what is actually harmful from the 3D printing. and I mean the ultrafine particles and volatile organic compounds. You know, that is the answer to what is safe in 3D printing and what is not. And it is not just about the 3D printers. It is about the materials and what do you put into them, because actually it is what comes out of the material when it's heated to the high temperature. And I'm very happy that with our Prusa PLA and PTG, we are able to pass this certification with flying marks, even on open printer, but our range has the same extruder design, so we already have it for Excel, and we are waiting for just the documentation on Core 1 and other machines. So that can give you peace of mind that when you are running a lab all day, you have these machines around, you can do that. Now we decided to push forward and do more advanced materials to really be the ones who can guarantee everything is safe and how to do it safely. But for the machines and the materials which are more advanced and we do not have the green guard, we also have truly great filtration systems for our machines, where you can print ASAs, polycarbonates without any trouble. But as you are all running the labs, it is a thing you have to upkeep, and you have to do regular service checks. So we also have like simple systems how to plug the machines to your fume extraction systems, so you do not have to worry about this at all. And then we have some super simple features which I'm surprised are not present by default on all of the machines. Probably a lot of you have an experience with workspace safety, so give a shout out to the reset and stop buttons which actually stop the machine. That is unfortunately not the standard in all of the 3D printers, so I just wanted to make this little point. And now, I was asked to share a little bit of our roadmap, and we usually do not do that much, but in this case, I've been wanting to talk about our system for management of your farms, 3D printing farms. We call it Connect with us. So I can promise this year it is on our roadmap that you will be able to run it on premise. That means no cloud. If you are really working on something which needs to be kept secret, or you have NDAs with someone, you do not have to go through our servers. But with the upcoming big update, the Connect is not just for managing the machines, but it is becoming true ERP for your additive manufacturing, where you can actually have custom quote requests either inside of your organizations if you are at the university, and what is also on the roadmap, it can be connected to your current user systems like Active Directory and anything, something like that, so you do not have to create new user accounts. And you can also expose this to the outside, so you can have just the files coming in, and you can also have the price quotation. And this also couples very well with one of our greatest things we've done this year, and we call it EasyPrint. And it is a slicer which can run on an iPhone. That is cool. But what I think is even cooler is that if it can run on iPhone's browser, it can definitely run on Chromebook without installing anything. So if you are running classes, you do not have to worry about installing anything. Your students can just open a website which is connected to the classroom, and they can slice away, and you can just check the files before you send them to the print farm, which I think really shows how great it is, the fact that we make everything under one roof. You know, there's 1,100 of us, and we make electronic design. We manufacture the electronics, including the SMT. We make the firmware in-house. We make the slicing software in-house. We design the hardware, we make the hardware, we assemble the machines, we ship the machines, we support the machines. And at the end, I get to interact with this amazing community. But when we are talking about the roadmap, over the last couple of days, there was one topic which was brought to I was asked a lot of the times, and that is what is the current stance on open source. So it is a difficult multi-layered topic, but I decided to talk about this a little bit here, but I did a write-up for my blog to have all the details. But here is a graph I did a couple of months ago, I think in March, and you can see that 3D printing, these are patent applications in China for 3D printing. And you can see that something really happened in year 2020. But I will start with a story. We just recently started to work on a successor to our multi-material upgrade 1 and 2, because the filament switching is not going anywhere. And we brought it to the 3D printing community as the first company in year 2016, 9 years ago. And we shared everything to the community. And most of the, well, I would say all the desktop 3D printing machines who do filament switching have parts of our MMU1 or MMU2 in there. So that is a fair game. But when we started to work on the new version, we suddenly realized that there are already patent walls erected around all of our inventions or designs we shared. And what the filament, for example, our MMU1, there is already a patent granted for it in China and in Germany, and the fact there is a prior art is obviously nice, but you can fight that in court, and that just takes, I don't know, 15,000 euros a year. So, and meanwhile, they can always stop you from selling the design, and you just have to fight it in the court. And this is not the only instance, Really, just the 4 companies have, over the last 5 years, have 2,500 applications. That is almost 2 times as much as, for example, Stratasys has in the 30 years. So, what has happened around the year 2020? The 3D printing got marked in China as a strategic industry, which means they started to get a lot of the support, and some of the stuff like pre-tax super deduction, where they are highly incentivized to file a lot of, I would say, like mass patenting of every idea under the sun, because they get to do 200% pre-tax deduction, which is nowhere in the world. And this is why I think really open hardware in desktop 3D printing is actually dead. You just don't know it yet, because the lag, because the IP takes so much time. When this started to happen 5 years ago, before the applications go to the West, and before we have the first big cases, this patent of our MMU1 was approved in Europe just May this year, if I'm correct. It will get much worse soon. But the open hardware is especially endangered, because everything is out there, and you just file it right away or do the minimal things. And I am really worried for the rest of the open hardware heavy industries or fields, because most of those are also also as parts of these programs like Made in China 2025. But as I said, it is multi-layered, and I decided to do a little write-up yesterday, and I did not want to swear too much during my talk. So check it out. And now, let's talk a little bit about my vision. And we did forget to ask for the 90-degree rotation. Can we do that now? Yeah. Oh, yeah. It's going. Good. Just 45? Okay, then 45. To the point. Wow. So my vision for the upcoming decade, I don't want to go all that deep, but I think it strikes resonance with a lot of people when I hinted. I really want to get the 3D prints to blend in with the regular objects you have around you. I think that over the last 15 years, I would say mostly 10, we've been optimizing for the wrong thing. With the FDM, we are using plastics, but we have a lot of plastic parts in our lives, but they are never smooth, because if they always have textures and different feels, and we've completely forgot about this in our industry. But we have, 30 types of red, shimmery, lipstick-like filaments. But when we reach our ultimate goal to have like the perfect wall, perfect perimeters, perfect layer stack up, it will just look like a cheap plastic toy. So I think this is something for our industry to think about and wrap our heads around it and really try to push the appearance of the objects to really blend in. That is what I think is the biggest blocker of the big adoption of FDM printing. It is not going anywhere because, compared to other technologies, the parts are immediately usable once they are finished. It is not messy, and it is very safe. And as a part of this, my personal mission is to make 3D printing a viable option for mass manufacturing. We have great experience with this. Who has visited our print farm over the last 2 days? Good. Wonderful. So we've been using it for, since the beginning. And we have some numbers, and at the same time, we also have a huge injection molding shop. So we have the experience. And a rule of thumb is that if we do not expect to make more than 60,000 pieces of that part, we just don't even try to do the injection molding. But imagine nowadays with the internet, you can have so many new niche businesses we could never have before. Because now you can always get a couple thousand people around the world who have the same hobbies and same interests as you. And with 3D printing, you are not locked behind the critical mass for that. If you have 1,000 of possible potential customers, you can start with 3D printing today. So I just want to bring this to higher scale so people realize that it is a viable option. And it will enable us to be more independent in our production. And the long-term vision, I also want to bring to the market a brand new technology which would be using just waste as the input material to create fully functional objects. So I would say that is all from me, from my talk. And I think I want to give a huge thank you to all of you. And we can start the Q&A. Will we be rotating for the Q&A? Or should we do the Q&A standing up?
No, there will be chairs,
Okay.
and we'll switch the view in the middle.
Okay.
So we won't be facing.
Or we
back.
can sit with our backs close to each other and looking outside.
Oh yeah. So.
Good.
Okay. So, that was quite a speech. If any of you have any questions for Joe, use the Aventi app. There are some questions there already, and I've been told that Joe is ready for anything.
Sorry?
You're ready for anything.
As always.
Okay, so, Joe, the most popular questions we have there is, if you could travel back in time traveling, is there anything you would like to change or do differently?
I do not allow myself to have these thoughts because, at the same time it would create a time-traveling paradox. Because then, if I would change those things, maybe I would not get to the point that I want to change these things. So, it's not. I always try to learn from, certainly we could have made some better decisions throughout the years, but, we just, to be comfortable with myself, I just need to be sure that I do not repeat the same mistake twice, and then it's better to focus the energy on moving forward than, ruminating about the past mistakes.
Okay. Speaking of time, do you get asked a lot about the future?
All the time.
All the time.
But, in tech, especially in something moving so rapidly as 3D printing, I do not want to become one of those, famous talks about, this amount of RAM will be enough for everyone, yada, yada, yada. I don't want to be on those lists of these quotes that they did not go well. I can see 2 to 5 years into the future, but yeah, that's it.
Have you ever made predictions that didn't happen?
I don't know. I think our brains are very good at forgetting the things that didn't work out. That's our sentimentality. We keep the memories for the good outcomes much longer.
Much nicer question. Thank you for all the votes and questions. What are the alpaca names?
So our alpacas, they are rescue because there can be only one male for the herd. So they usually let's not talk about that. But we now have 5 boys. When we brought the first ones in, we asked the team to name them, and surprise, surprise, they named them Josef, Andre, and Michael, the three Prusas. And I have to say, when you see these things, it is not me who is giving the orders that, hey, let's put Joseph's face on this, or let's name the alpacas after me. It is just my silly team.
I'm part of that team.
And we now have two younglings, and one is Dusan, and the other one is Kubik.
When will Prusa release the XXL?
Okay, I would say sometimes between now and 5 years in the future. Okay. That was the biggest no answer I could have thought about, but thank you. Or did somebody slip from the tour and saw something out there?
Hope not.
Okay, good.
Do you have other plans besides 3D printers?
See, with what we are doing now, well, actually yes, but it's still closer to 3D printing, and that's just around the corner. But you know, I would say we have trouble of getting enough like brilliant engineers. We kind of have all the people which are available, and I still feel that we are just barely touching the sort of surface what is possible with FDM. So if there's a limited pool of brilliant engineers for us available here in Czech, it would just mean that we defocus from the main thing, from our main machines, and start something new, which will take 5 years to actually get good at. So I say we will stick with 3D printing for quite some time, until I feel that there's not much to improve. But I have a feeling that that will not happen for a long time.
By the way, do you personally still 3D print, or is running a company making 3D printers enough?
Oh, I do. Oh, I do. I mean, all those benches and bunkers benches and stuff like that. I do that. I do test it before it goes out, so it's like truly perfect. And just recently, a couple of weeks ago, I got back into the coding. So I've been hacking on Slicer and on the firmware, and I'm very excited that I found out some completely new techniques, and it's amazing. I have a small office at home. I have 2 Core 1s, one 5-tool XL, and the HT90.
Ooh,
yeah,
quite a setup.
HT90 is a perfect printer for home.
Your wife thinks so.
Because you know why? Because you can use your oven to dry the filament. And my wife loves that.
Okay.
Hi, Bara.
My wife told me, like, what's this thing doing here? You're gonna like this question. Where's the secret silo with all the Haribo gummy bears?
Well, I think they are stored here in Holešovice in our warehouse. But you know the story how we started to include the Haribos? It is, when we for the first time started to do the kits and ship them, we know that when you are starting something like that, there will always be mistakes. You can put as many spare parts in, there was, my experience is that there are always new ways how to, assemble something wrongly, break something, or, a new defect of the parts. But long story short, we said, like, hey, let's put something nice in there if something goes bad. And we had a brilliant idea to bundle in a chocolate. Let me just say that I think there was 0 chocolate bars which arrived in a pleasing state. So you need to be ready to do quick pivots when you run a company. So we made an executive decision. Let's not do chocolate. Let's try Haribos. And it became sort of our thing. And I think everyone enjoys it so much, even though it is so silly. It just means that when it's the first interaction of us and the customer, the user, the new member of the community with us, it is a nice start. And we are, I think, definitely the largest customer here in Czechia, after the big chains. But I think we are touching the numbers of like the big retailers. And you can see at certain point we had like wall of pallets of Haribo bears.
Whose idea was to pack 1 kilogram of Haribos with the XL?
I mean, I don't know, but it is just so obvious that we bundle the tiny pack with the mini, we bundle the normal pack with the Mark IV Core 1. Then with XL you have to have a giant tub. But, I mean, but of course, we've at the very beginning, the tab was, even though we tested it, the big tub, sometimes it didn't last the shipping because it's very heavy, and so I'm very sorry about the couple of very sticky printers from the early Excel days. I'm truly sorry.
Okay, down to a serious question. Why do you believe it's so important to remove Chinese companies from your supply chain?
Oh, I think it makes sense if I want to really be able to speak freely about things I find. It is just so simple to be. If I would have like half my parts made in China, it would be just so easy to export limit us, and have us under obedience.
Okay. Is there something the Průša user community still doesn't fully understand or appreciate about your vision or the product?
Ooh. That is a question I would need to sit down and think 20 minutes, because I just don't want to blurb something out. Maybe let's circle back to it. I hope it will be on my back burner.
Okay. This is a simpler one. Is development of a metal printer one of your future goals?
I would say let's do that when we are done with the desktop kind, the kind you can have at home. The metal powders, it is, people outside the industry do not realize this all that much, but the powder, if it's in the air, it can be highly explosive, and you don't want to breathe it in. And I just enjoy making the high volume machines, which can change a lot of lives. So until I feel that we succeeded in this, we do not plan to go to the metal manufacturing just yet. And there's a lot of companies already in that field.
Okay, time to switch sides.
Okay. Oh, we are not rotating.
Hey guys. Is it time for patents in open hardware?
Oh, go and read my article. I'm not sure to say it this way, but one of the closing remarks is in that article is how the hell we did get to the point that you have to think about protection of your designs to be able to share them safely. Because the fact that you do it as we did for the long time just enables everyone to do the patent wall around it. And even though if there is a prior art, to get one of those applications, if they are granted, down is up to tens of thousands of euros. So this is I have some questions and some ideas for thinking for us as a community, but I would maybe we had to do over the last few years we've done an early warning systems for these potentially harmful applications for our industry. So I would like to invite anyone from our industry who wants to prevent desktop 3D printing from getting gridlocked by patents, that to contact me, and we can share notes, and maybe together we can start an organization which purpose would be to keep 3D printing truly open and available to anyone. Because right now it seems that we are roughly 5 years from not being able to do anything unless you want to be sued. So it is really, dire situation. Unfortunately, it is. There were no big public problems, so people are not aware of this.
What 10% parts come from China and why? Especially if 90% can be produced in Europe.
It is easy. It is the motors, because I mean you just cannot get the volumes we need. You just cannot get them in Europe, and for those we have alternative suppliers, but you know we are not I do not think that if we would charge $50 more for that people would be willing to do that. And a couple little things. But at the same time, I'm very happy that we have a couple of ideas how to design special new motors without any rare earths locally here. That is also a project for next few years, because you know the motors are sort of a strategic supply too, especially you know with all the robotic arms and you know upcoming humanoid robots. You know, all of these machines have motors in them, so we should really think about it as a strategic supply too.
Why is there a fish in Prusa store?
Oh, you are talking about the magnetism demonstrator? Well, we just wanted to have something that shows the easy modulability of our new machines, the core ones, with magnets. And you know, we just happened to be in Japan, and we found the perfect device to demonstrate the magnetism of the machine, because the fish has magnets embedded into it. And you can buy them on our shop, yes.
People are asking a lot about when is the Prusa Mini 2 coming, or are we working on an MK5?
Wow. Well, I would say the Průša Mini will come out between now and 5 years in the future. And MK5, we plan to keep the MK4 or i3 line going for much longer, because somehow, even though the core one, you know, is better in every way, I still love that machine, and a lot of people love it too. I mean, if we are talking about, we are never going to quit making the kit printers, because they prove to be completely invaluable as you know, an engineering educational toy. You know, the STEM toy. It is the ultimate Lego, because you get to learn how the machine works, but at the end, it is not a toy. It is a machine, the same machine which is used by, you know, NASA and other. It is incredible. So I vouch that we will keep making the kits for a long time. And I think, you know, in this regard, the i3 style machines are the perfect design.
We're nearing the end of the Q&A session, so any thoughts on that question?
Can you read it again?
Any thoughts on that question? It disappeared from my... yeah. Yeah, please. Can you put it in again?
Oh. Okay. So, what I think the community I get to interact the most with understands you know, the values of us, but at the same time the general community, the guys coming in over the last couple of years, you know, they I don't think they appreciate the importance, because you know they got hooked, which is completely valid, but by printing flexible toys on TikTok and buy through TikTok shop. So I think this is we should do a little bit more education for the people to realize that the device they have at home is not just to make silly things, but it can really help them, you know, start a completely new career, for example. Okay, I think that's a good end.
Yeah, yeah.
Thank you very much.
Thank you. Thank you. That was Joe Prusa.
It has been 5 years at least since I did my last talk. I was mortified at the beginning, but I enjoyed it immensely, and thank you all once again. See you throughout the day. I'm here. Enjoy.
So that was Joe Prusa. Thank you all for your questions and for your time. I hope you enjoyed. And we kept you here for an hour and a half, so it's time for refreshments. We'll take a 20-minute break, and we'll see you all here 10:55. Thank you.
Some places claim to be the most advanced, the most connected, the most knowledgeable. But what actually makes a place just perfect? There are always tiny steps behind the big picture. Like when the greatest scientific discoveries start from the smallest things. Yes, it's peas. Our Brno region might not be big, but its ideas are. Bold plans, smart tools, and the drive to break through. There's friendship, if you want to, collegiality when you need it, and closeness with everybody. Long story short, it's like one creative family here. Everyone knows everyone, which is great for sharing knowledge, of course. And the best part is, all these people live in a unique space of 12 universities, top science labs, and modern research centers. The perfect mix for innovative businesses. Because what you do in Brno region stays in, well, the whole world actually. We are the mecca of electron microscopy. A third of the world uses computer antivirus invented here. Many revolutionary innovations from biotechnology and nanomaterials come from Brno. But how did we manage all these big things? It's because of these little things in life, like feeling safe at all times, which is pretty simple when you live in one of the safest places in the world. In fact, our worst natural disaster is this burning stump. Yep, true story. Besides, Brno region has a tradition of being open to everyone. Easygoing, life-embracing, not so touristy, and with perfect prices, they say. Oh, and did we mention everything here is really, really close? 3 capitals are just around the corner. So that's why we don't need to claim we are the biggest and the best. We know that perfect is what feels just right.
We're back and right on schedule. Thank you all for returning, and what lies ahead of us is a set of free talks by the huge 3D printing experts we brought here, and you're in for a treat. Please, welcome to the stage a man who helped to shape both the tools and the culture of the maker movement. Welcome a man whose name you'll read every time you boot up Průša Slicer. Please welcome Alessandro Ranoluchi.
Thank you. Hello, everyone. No spinning for me. So this speech is going to be a little time travel for me because I'm going to talk about this project, which kept me busy for 10 wonderful years of my life. Everything started, so at the time I split my brain into different lives. I was 50% an architect, physical architect, and 50% software engineer in love with open source projects, going to open source conferences and so on. At the same time, making models for competitions of architecture. So I was spending time and money actually paying for expensive 3D printing services with SLS machines to have those models made. So at some point I was Googling, is there an inexpensive way to make those models, maybe a DIY solution and so on. And actually there was one, you remember all those pictures, this was the RepRap community at the time, so a forum, early prototypes and so on. You all remember this picture. Hi Vic, are you still in the room? And the family tree of machines built by people all around the planet with children, grandchildren of machines and so on. So this was a fascinating story. And there were people, sorry, Joe, people like Joe inspiring other people with brilliant solutions shared from their bedrooms and basements around the world. In addition, I want to mention a few other people who were inspiring for me at the time. I want to mention Clement, the original author of Pronterface and the Sprinter firmware, very active person in the community at the time. I want to mention Notepad with his blog with calculations and some theoretical thoughts about 3D printing. I'll mention Richard Horn from the UK with a very colorful blog trying to bring some aesthetics to DIY 3D printing. And also Marius Kintel, the author of OpenSCAD. These are just few of the people who in the very first times for me were inspiring and brought me into this community. An IRC channel, RepRap IRC channel, 500 people at the time, talking from all over the world and exchanging ideas. So I jumped there and I said, okay, I really want to be part of this story. This was the mood at the time. People were building stuff like this. So how can you not join such a movement? Crazy enough, I kind of missed this chance. So I got my first open hardware printer from Germany, a kit, the Shippercube, super sturdy machine. I still have it. It's not working, but that's where I did my first experiments and actually learned to solder and actually got my first prints. Okay. Could be better. I had the feeling that something could be improved on the software side. At the time, we were using SchemeForge. Who used SchemeForge in this room? Anyone who's using SchemeForge? I see some hands there. Okay. So SchemeForge actually opened a lot of possibilities. SchemeForge was a glorious project with a lot of options, probably too many, and actually I felt this was a limitation because it was, on one side, it was slow. It could take even 40 minutes to generate G-code for a project. So iteration and experimentation was hard with this time. It had no visual preview. You couldn't rotate the model and prepare the print and see it before printing. The settings were hard to understand. As you can see in the screenshot, there are settings like orbital feed rate over operating feed rate expressed as a proportion. So it's very hard to understand how to tweak those numbers because they do not relate to a physical, something that you can observe physically. And the code was hard to modify. So for a programmer, it was really hard to contribute and fix stuff. And the development model was not really open. It was open source software, but there was not a community and a process to get contributions and so on. So I decided to start coding because those machines could do more, in my opinion, and the software was limiting what the hardware was able to do. So in the end, slicing a mesh is not hard. You have a triangle mesh. In the end, you iterate over each single triangle. You have a Z you want to slice the model at. If the triangle is above the Z, you ignore it. If it's below the Z, you ignore it. If it crosses the Z, you just calculate the segment. It's basic math. Then you collect all the segments, and then you build polygons. Polygons with holes. So each solid sliced produces polygons with holes inside. At that point, it's just 2D. It's not 3D anymore. You just use booleans to intersect layers. If a layer does not intersect with the neighbor layer on top or below, it means it's an external surface. Then you need to fill it as an external surface. So in the end, it's not rocket science. And then you use offsetting algorithms to build the perimeters. You come up with the creative ideas to generate infill. So in the end, you generate the bounding box of the polygon. You generate a number of parallel lines. Then you cut them, and then you get the infill. This was the first print made with Slicer after 1 month of coding. So actually doable, not that difficult. So building a prototype was easy. And then everything else started, because you need to deal with non-manifold corrupt STL files. You need to build a graphical interface. You need to build a graphical preview. You need to compile and distribute for multiple platforms, and so on. So this is why the project that was apparently working in 1 month took like 10 years to reach a stage. This was one of the first releases, and then after some time, this is the last one released a few years ago now. So this is the state I left the project a few years ago. So with a graphical preview, features, and so on. The process was very nice, because the community all around the world was sending me pictures, screenshots, but pictures of prints, of failures, saying, I tried your build of last night and it didn't work. And this is why. So people were testing, helping me much faster than I could do myself with my printer. And as in proper software engineering, I was turning those reports into unit tests. So a collection of hundreds of unit tests representing each single failed print, which is not that easy, because G-code generation is not deterministic. So you cannot inspect G-code line by line. You need to understand if the result is consistent. At some point on the official RepRap blog, this was published, announcing that thanks to Slicer being a bit faster, this new thickness of layer height was reached for the first time, just because Slicer enabled the faster iterations. Then I decided to fly to Prague, and I stayed in Josef's basement for 10 days. We had met online, 2 guys chatting behind nicknames on an IRC chat, and said, why don't we hack together for 10 days? And so we recorded this YouTube interview on a hill here in Prague. It's on YouTube, and we were exchanging our first thoughts about what 3D printing could become. Joe's tattoo on one arm is generated with Slicer, and at the time. Donations, community, corporate sponsors, there were even more. This is an old slide, but just to tell you that companies making profit from 3D printing jumped onto the project, supported me with regular donations, which allowed me to dedicate time to this project, and also to pay, compensate other contributors that helped me move the project forward. The Slicer was also a sandbox to introduce new concepts. For instance, this is just one example, the brim. The brim originated as an invention in Slicer. How should we call it? How should it work? And then it's something that now is normal. So also inventing terminology, but also inventing concepts like multi-material or multicolor printing. This was made in Slicer, and these were the very first prints made. Now these things are normal. At the time, they required actually inventing, deciding whether it was worth investing all that time into something new that maybe could be working or not working, or useful or not useful. Or like adopting different layer heights in different parts of a model, for instance, or the ability to decide different configuration options for different regions of a print, if you wanted to, for instance, reinforce part of a print. So all these features required a lot of re-engineering work of the entire project, and they were experiments. I felt like I was enabling people. My role was not to invent things myself, was to unlock what was missing and what people were needing to innovate and experiment themselves. So I was feeling I was an enabler. I tried to engineer Slicer as an application built on top of a library, of reusable components, so that if people wanted to make software for other machines, lasers, CNC, other kind of robots, they could reuse STL file repair, perimeter generation, path planning, and so on. So as a collection of algorithms. Examples, for instance, of stuff that Slicer uses, but you could use in many other applications, for instance, like path planning. Something I really wanted to do is to write very clean code. because I felt that the world was reading this code as a way to learn how to do slicing. So I tried to write clean code, well commented, as a way to foster more innovation and actually spread the knowledge of those algorithms that I was reading from papers and implementing in code. I was building my own debugging tools. This is, for instance, a tool that generates a vertical section of a G code so that you could see exactly where the printer would print the paths given a plane, intersecting plane, as a way to check whether supports or overhangs were correctly handled. The community was posting issues, bug reports, suggestions multiple times per day. That was my life. I loved interacting with the community. It took a lot of time, of course. Scaling the project was about a number of things beyond coding. For instance, managing consensus. Of course, being the main maintainer of the project means you are the dictator. That means you actually need to bring the community with you. So decisions were not very easy to make. For instance, around every single feature, there was this debate. Shall we put one more configuration option to make Slicer more flexible, more configurable, at the cost of making it more complex to use, more complex to understand? Oh, one more option that could go wrong, and so on. So this was the endless quest for flexibility versus configuration option creep. Another thing that was a problem for me was, should I accept pull requests that are mid-quality, lower quality, or should I keep high-quality code with a high standard all the time at the cost of slowing down the project and becoming a bottleneck because I couldn't review all the pull requests and even the other people were not doing it at the necessary speed. So these were my concerns at the time. Books were printed and written by people around the world and published explaining how to use Slicer. I was reading them and learning new ways of using Slicer myself. It's not a joke, it's an interesting way to learn from users. Thanks to donations and sponsors, we also put effort on writing documentation, which is something every open source project forgets. And at some point, with the birth of the Marlin firmware, I had to decide whether Slicer should stay firmware agnostic, so able to work with any firmware, or optimized to work with a very active project that was under development. So actually with the Marlin team, we collaborated a lot because they were introducing new features and Slicer was introducing features that would only work with Marlin. So this was a sort of a political choice to bring the quality forward. Contributors from the community offered other kind of contributions. Designer contributed the logo, this logo, and an attorney in love with 3D printing contributed trademark registration because Slicer is open source, but like many open source projects, has a trademark on the name and the logo as a way to make sure that there is a bit of guarantee on how the name is used, especially with the rise of companies starting to use open source with their commercial products. At some point, something interesting happened. So Joe mentioned patents. There was a time in the 3D printing history that some companies started to patent stuff that was already circulating. So messages like these started to arise. Oh no, I did something, it's public, but they are filing a patent. Examples, this is just one example that affected Slicer. So this is a patent about slicing. That patents are kept secret for some time before they are made public. So 2009. This is about a way to cross the ends of a perimeter before leaving it so that the seam is not visible. This was in the patent. I implemented this in Slicer while the patent was secret. So there was no way for me as a hobbyist to know that that was patented. So we, as open source developers, we were stepping into someone else's field, to be fair, at the time. Problem is that that patent not only was made public, fine, okay, discovered, oh wow, but it was also updated with details that were introduced in Slicer. So details like the length, the angles, and so on were put in the patent like 2 months after they were published on GitHub. This is just one example. I have many other examples of things that were taken by the GitHub repo and transformed into patents. So at the time I was very scared because as an individual, as a hobbyist in my bedroom, how can I manage an issue with those large companies? So luckily the EFF helped in handling those things. Luckily nothing happened, but this of course could be worrying for someone trying to do something this big with your just in your room. So beyond development, Slicer kept me busy for many other things. Community relations was a big part of my job there. Working on bugs, backlog grooming, all the housekeeping stuff was really strong. Google Summer of Code initiative that we did together with 3 other open source projects. We joined the forces and we had Google Summer of Code students working with us and traveling, conferences, hackerspaces, media attention, all nice, wonderful years, still taking more time from development. Increasing pressure, because at the same time I had more ideas, I had community telling, why don't you do this? There is a new open source project implementing this feature. Oh, Slicer is crap because it doesn't have this feature. And I was feeling bad because of this. So request, criticism, it's normal, it's perfectly normal. I'm just openly telling you the feelings of an open source developer. Too many ideas, not enough time to make them real. Time to take a break. So a long break, I configured a filter in my mailbox. Everything containing Slicer went to a hidden mailbox. So for a while, I disappeared from the project. I needed that. Basically, what happened is that I silently quit the project. And a nice thing happened. So this, for me, is a lesson learned. Suddenly, new people, new contributors, new maintainers emerged from nowhere. And I learned that if we spoil your community, talents will not emerge. I was trying to do myself too many things, and people were not feeling the need to contribute themselves. So that was incredible. Very good contributions, and even new co-maintainers they promoted to the repo and so on emerged just because I was less active than before. So lesson learned that I share with you. And also forks. So Prusa Slicer is the most well-known fork. There are others by other companies, independent projects. So the Slicer code base is somehow living in more modern, more maintained projects with very skilled developers, with good funding and so on. So actually, quitting the project at that time was not a bad thing, actually. It was the kickstart of more innovation of the project. And open source lives beyond people. So when you know this from the beginning, you are not jealous of your baby. You're not jealous that they could take your code, change the name, reuse it, as long as they respect your license. That's part of the game. So that's it. This is Slicer's story. Thank you.
Thank you, Alessandro. Up next is a tale of speed, scale, and some serious 3D printing. To tell it comes a man who you might know as a guy who makes reviews, videos, tutorials, and somehow keeps positive and smiling all the time. But for me, he remains the guy who took me for the best burger on the entire West Coast. I give you Joel Telling, the 3D printing nerd.
Check, check, check. Hey, everybody. Hey, if you could keep the applause going for the crew here at FAB25, just keep it all going. I mean, they're doing an amazing job, right? Yeah. Yeah. Oh, man, look at my big dumb face. So I am Joel, host of 3D Printing Nerd. And on the channel, 3D Printing Nerd, we make lots of content that tends to inspire and educate. And as well as doing that, we have a print farm. And so this is going to be a story of print farm efficiency. And so how I printed 80,000 parts using 50 Průša 3D printers. Like I said, it's a print farm efficiency story. There it goes, told by me. I made all the slides myself. I'm really sorry about that. Okay, so first of all, look at this. Look at all these friggin' boxes here. These are most of the boxes. I think it's 44? I don't know, I didn't count. But the goal was to install 50 Průša Mark IV's 3D printers for this job in the 3D Printing Nerd print farm. And this job was with Spark Fun Electronics. They make a lot of kits and little project electronics that you can use in your projects. For them, though, it was 80,000 parts for 10,000 of their XRP robotics kits. You may be asking yourself, what is an XRP robotics kit? It is this, the Experiential Robotics Platform. It's an open source robotics platform that utilizes sensors and motors and a lot of determination and imagination for kids of all ages to be able to experience robotics and to kind of get them going in thinking about robotics, because this little thing right here, printed parts, sensors, motors, wires, servo motor, it also uses something called the WPI lib, or library. And that is a code library that is used by FIRST robotics teams to program the big robots that they used in those competitions, like these big, massive, multi-thousand-dollar robots. And so this is the perfect gateway drug for getting kids interested in robotics. The kit itself has these parts, and each kit is just these 8 printed parts. You can see there's 2 wheels, so it's 7 individual parts. One of them is repeated. And again, 10,000 kits, 8 pieces per kit, 80,000 parts. I want to say that over again because it's not like the print farm was set to print 80,000 of the same part over and over and over again. Just like Joe mentioned earlier, he said if you need more than 60,000 of a part, that's when you tend to look towards injection molding. And we have lots of different parts here, so it wasn't even a consideration. Plus, this is right for 3D printing because while we were doing this, they made changes to the model, and we could insert those changes directly as we are doing the printing, and so we were able to pivot really, really fast. So the parts, first of all, there's a battery clip. And I'm going to take you through the parts and how I'm kind of evaluating them for a print farm job. It's small, it's flat, and it's easy. Small, flat, and easy. It's the best kind of part to print. Next up, it's going to be the chassis. So this is the largest, and it's also the longest to print. It's been engineered, and you don't even need supports to print it. Like it's a really, really cool part. And like I said, this is all open source. You can go to Printables, download the files, and print them yourself if you really wanted to. And I encourage you to, because robotics is cool. Next up is the lifting hook. It's the thing that attaches to the servo at the end, so you can lift things. It's small, and it's simple. So easy part to print, right? We like our easy parts. The next one is the line sensor. So you've seen those robots that follow a dark line really fast. That's what this sensor is. It can sense the contrast and follow the line. The way they designed it, though, it sits on its edge, just like that. So it's a little bit tricky because there's not a lot of surface contact. I don't have a slide for it, but in doing print farm stuff, adhesion was never a problem. There were times when we had some lift with things, but just as a freebie here, if anybody's running machines, adhesion helpers are great insurance. And if you're going to run lots of parts, it pays to have insurance. There you go. That's my freebie for today. Next up was the servo mount. So this part clips onto the chassis and holds the servo, which the arm attaches to. It has limited contact geometry. So those little legs that you see kind of at the bottom there, they're almost just 2 perimeters wide. Sometimes when you're on the edge of the plate or a draft comes in, they would tend to lift a little bit. And so again, adhesion helpers, they're key for this. The ultrasonic mount, similar to that other one, it does print on its end. It is a mid-sized piece, and it is a slightly longer print just because it is bigger. The wheels, though, they're wheels. They print flat, right? There's 2 of them per kit, and they print really, really fast. And so I really like those. All right, so I've introduced you to the parts, and that's me. That's me holding a plate with a chassis on it. That's a good picture. So during the early print process during the early prints, there were challenges in the process. By we, I mean me, because it's me. There were no consistent layouts on the plates. And so we've all used 3D printers, or we know about 3D printers, I would imagine, by this point. And I would just jam the parts into the plate. How many could I get onto that plate to really take advantage of the size? And so initially, that turned out to not be the best way to do it. Also, there was manual counting and human QC. Early on, I didn't use the robot's ability to count the parts. I used my mushy brain's ability to count the parts. And so I would harvest plates, or my wife would harvest plates, and we would just dump them into a box, and we would have hundreds of parts in a box. And then I would count out parts to put in a bag, and then before it got put into the shipping box, we would count the parts again. Super, super, super rife with error, like frequent human error risk. I should have put that in red because, oh my goodness, the amount of bags that went. As long as we had more than enough, that's what I was really not too worried about. So there were light bulb moments during this entire process that really led me to shape the way that we were going to run the farm for this project. When we started out, again, we were kind of like this, and as we started to course correct, we narrowed down, and we had those light bulb moments to kind of help us adjust. So kits were shipped in batches of 50. We would have a box, and it would have 50 parts of everything except for the wheels. It would have 2 wheels, obviously. And so what I wanted to do was align the build plates to the packaging, meaning build plates could contain 10 of something or 25 of something. And when we have 50 machines dedicated to this, it really makes a lot of sense. And that means the machines can count the parts. Robots can count parts way better than our mushy brains can, or at least in my experience. I don't want to speak for everybody. But I wanted to, at this point, print for the packaging. And a little rainbow, a little shiny rainbow there. So now we're going to go through the parts. And now that we've learned these lessons, we're going to find out the best way to print these. And that helps us sort of plan certain things because, as an example, the battery clip, I can fit 10 of those on a build plate. I originally put like 12 or something, and no, that's not good. Let's do 10 because we can manage that really easily. 10 of them, and it takes an hour and 11 minutes for 10 on a build plate. The chassis, like I said, is the largest and the longest single part to print, so it's 5 hours and 3 minutes. And the lifting hooks, they're skinny. I could fit 25 of those per build plate, and it took 3 hours. On the line sensors, 25 of those per build plate. Remember, they stand on the end, 3 hours, 53 minutes. The servo mounts were 25 per build plate. That's right. I kind of had to nest those in, kind of make them fit, but it seemed to work. And 3 hours, 29 minutes, 25 per plate. The ultrasonic mounts, remember those were kind of the mid-sized part that I identified. 25 per plate, 10 hours, 7 minutes. Remember that number, 10 hours, 7 minutes, because it's going to be important for what we talk about a little bit next. And the wheels, 10 per plate. And I can do 10 of those in 2 hours and 13 minutes. And now it's, obviously with this graphic, it's time to do some math. And I would imagine we're all fans of math if we're at FAB25. So throughput numbers, this is where it gets really, really exciting. And this is where we started to refine the process and really start to explore the efficiency side of how this print farm job was going to be going. So the chassis, remember those were 5 hours, 3 minutes. And if we have 50 machines, then we could do technically with assuming no failures, let's just assume no failures. We can do 150 per day, and that gives us 1,050 per week. And that's pretty good. That's pretty good. What we could do then is take that 1,050 number, and let's have 1,000 be the shipping number. So we could put 50 in a box. 20 boxes gives us 1,000 kits. So if we have 1,000 chassis, we could get 1,000 chassis done in a week. That's awesome. The battery clips, remember, those took, 1 hour and 11 minutes? Something like that. For 10 on a build plate, 50 machines, that gets us 500 in 1 hour and 11 minutes. So then another 500 would be another hour and 11 minutes. And all of a sudden, we have 1,000 battery clips in under 3 hours. And again, we're printing for the packaging. And so it's easy because we just pull from the plate and we squeeze into a bag and the machine has counted it for us. And it was, these light bulb moments. Like, I hired my wife as well to help run the print farm because she's freaking awesome. And this just made her day. It was great. The wheels, 2,000 per day. With those wheels, remember, if there's 10 per build plate, then we can do 500 in the time. I think it was like 2 hours and something. And so if we want 2,000 in a day, we could do that now, and the machine counts it for us. And then parts with 25 per plate, 1,250 parts per run, because we've got 50 machines, 25 parts per build plate, 1,250 parts. It really started to make sense. It was one of those things where early on, I had actually hired my kids too to help count stuff and pull supports and try to keep the shipping schedule up. But as we started to refine the process and make it more efficient, I didn't need my kids to work as much. They may or may not have liked that. But also, we were more consistent in the numbers we were delivering, and we could plan the shipping schedule really easily. Throughput numbers, like, I'm going to hang out here for just a second because math and 3D printing go together like peanut butter and jelly. And being able to take these numbers and come up with a way to make the machines go faster, be more efficient, and produce better parts and make it easier to pull and easier to start again. It was just wonderful. So the shipping cadence, there we go. The shipping cadence. Oh, look at that. My slides have a backdrop shadow, but the words aren't there. This is fun. The shipping cadence. So again, like I said, there was 1,000 kits shipped every 3 weeks, and we got 1 week getting all the chassis, and the accessory parts we were able to get kind of within that next week, and that gives us time to ship things. It takes time to pack 20 boxes properly with somewhat fragile 3D prints to be able to ship across the country from Seattle. So it was really important that we also were efficient with the printing so we could be efficient with the packaging. That wasn't me. Jeez. All parts are aligned to box quantities. So again, that's what we talked about. The boxes themselves had certain amounts in them, and we used the machines to count the parts that went in the box, and we didn't have to use our mushy brains and our error-prone ways in order to count the things. And it was just one of those. It was one of those things where we were able to confidently now ship out all of these pieces every 3 weeks. It was a cadence that was set, and it was great because it meant that as humans working, we could sleep. We could run a 24-hour shift if we wanted to, but this cadence let us sleep, and we knew when people had to go in to check things, and it also meant that when my wife and I and our kids, we took a little vacation over to the Hawaiian Islands, what we could do is train our friends and their kids, and then they were able to really easily pick it up and run the prints on the farm and help us keep the numbers up. Even though, I mean, it's 3D printing, it's a process, but we made it so efficient and we planned it so well that we're able to now teach people really easily to do it. And I think that's really cool too. So the system, it is predictable and it is repeatable. And that is the perfect system. Something that is repeatable and predictable is amazing because you can do so much with it. Oh, look at me. I'm tending the farm. I think that's when I was installing the farm. You can see parts on the bed. Takeaways and lessons. So I can't stress this enough. Print for the packaging. It is crucial to print for the packaging because you take human error out of the equation, I mean, as much as possible, and you let the machines count for you. And it's one of those things where I didn't think about it at first, but once I thought about it, I can't see any way I would not think about it in the future. Again, you're automating the part counting, and that helps you schedule things. Remember, repeatable processes, that's the way to do it. Smart scheduling is greater than speed. So I thought by stuffing those build plates with parts, I was gonna get more parts. But then that meant that my pull times were different depending on these multiple parts on machines were finishing. And so by scheduling the parts and printing for the packaging, we were smart about it. And that meant we were able to do things faster while still maintaining our sanity, because it's important that we sleep. I shouldn't have to stress this. It's important as humans that we get some shut-eye, because it's good. It feels nice. And this allowed us to sleep and be humans. It's wonderful. And finally, scalable from 1 to 1,000 printers. So I used 50 Průšas for this, but the process that I'm talking about can be applied to you if you have a printer in your garage, or 2 in your office, or if you have 5 on a shelf somewhere, or if you're like Průša themselves and have 1,000 or more in their print farm churning out parts. Using this sort of process, it gives you repeatable processes, and it makes things more efficient, and it lets you plan things out and deliver on time. And I think that's how we utilize additive for a future manufacturing technology, is everybody with 1, 2, or 5 machines who wants to kind of get into the game is able to spec parts, print parts, plan parts, and pull parts at a repeatable process. Oh, there we go. So what do we learn? Efficiency is quality plus happy humans. Again, we went for efficiency, and we made sure we can sleep, and that made us really happy. Oh, well, and you know, I make YouTube videos too. So as the host of YouTube videos, I like to say at the end of it, don't forget to print all the things. And in this case, almost 24/7. But again, stressing it, we could run 24/7. You could run 24/7 if you wanted to, but you don't have to if you've planned everything correctly. And really, don't forget to hug each other more. Aw, look at that. Look at that. And I think that's everything. Yeah. Hey, you know what? Thank you for listening to me ramble on about print farm efficiency. And I hope you really enjoy the rest of Fab 25. Take care of yourselves.
Thank you very much, Joel, the 3D printing nerd. And for our last talk, we will take a deep dive into the fascinating world of robotics. The man coming to the stage has more than a decade of experience in the field, and he leads an independent research group focusing on printable soft robotics. please give a warm welcome to Mr. Falk Tauber.
Thank you. Oh, that's nice. So welcome, thank you very much. My name is Falk Tauber. I'm from the University of Freiburg and the LIFMAS Cluster of Excellency, and I do, as you see, 3D printed, bio-inspired soft robots. So you might think, what is a soft robot? You can see this little guy below here, and I also brought one with me. They are made from very flexible materials, so that's the key aspect here, compliant flexibility. And you think, okay, what's the difference to a normal hard robot? Normal, if you take a look at these normal hard robotics, you can see them in companies, in factories. They are mainly made out of rigid connections, have different actuators, electronic parts, mostly very, very rigid things. You need a controller for them to be computed, to be programmed. You need sensors, actually, so that they're safe to work with everybody in the company. They need sensors to not harm anything around them, and they need sensors to actually be able to handle parts and more fragile parts. And this is in complete contrast to, for example, biological systems, where we don't really need to have a huge computational power to actually be able to move up and down these stairs here, because if I start thinking about it, I would trip. And biology and nature uses actually something very cool, which is morphological computation. So by design, I am able to move my leg that way, and not at many different angles, because I would break something. But we have like a rigid inner part, we have muscles, we have tendons that move in a certain degree of freedom, and we don't need to really think about it, because we have implanted these ideas here. And the cool part is you can also do it with completely flexible systems, like this little octopus here, who's able to actually grab a very hard shell, take it away, run or crawl over a very compliant surface here, sand, and can dig away and even come to another place, and maybe even build his little home here, also very compliant. He's completely, the only hard part here is his beak. And you can see he can even hide himself here. So it's very nice and high flexibility, and that's what we use in soft robotics, because there we have a complete soft system based on soft materials like silicones or even 3D printable TPU parts. It started with curing these things. So we used silicons back in the day. We would cure them, we would build them, and then we get like distributed actuators all over the body. So we can actually make those then move in different ways. We have multiple degrees of freedom here. And we use one of the main things that we use is pneumatics. So we have a compliant body that is actually pressurized with air. When you see these air chambers here in unpressurized, they're normally just like flat, and then they bend into the direction of the smaller stiff parts here. And that you can use them then to do interesting things. And with modern technology, you can really also 3D print all of these things and make, for example, self-adaptive grippers. Like you can see here, this is a fully 3D printed gripper, 3-finger gripper. And what's cool is we can inflate it. It can grasp an object. Here we have a can full of Coke. And the cool part is it actually configures itself to the object. So it can hold it, it doesn't squeeze it, doesn't crush it, and if you even increase it, it would bend away again and keep the full compliance. So it's really, really safe to use in, for example, human-machine interaction, and you don't break fragile parts. As I said, I do bio-inspired things and use bio-inspiration not only from animals but also from plants. So we also do carnivorous plant-inspired systems. They're soft robots, hard robots, for example, an artificial Venus flytrap gripper. And I have a workshop in the afternoon, so if you want to see that thing and play with it, you can see how we printed it. And we also do medical devices that are 3D printed that can save lives with a trick of nature. Here, the very fast snapping motion, closure motion of the bladder valve. It's actually quite interesting because that is the fastest plant motion on the planet. It takes 50 milliseconds to open and close its trapdoor. If you want to see that, I can show you the slides later in the workshop. And we do animal-inspired systems. So we look into nature and say, okay, there's, for example, the tendon locking mechanism of birds. That's the reason why they actually don't fall off trees, because they lock the tendons when they grasp. And they can sleep with that and don't fall off, but they really need to learn how to reopen that. Again, we transferred that to a fully 3D printed gripper system, and also we built insect-inspired 6-legged robots with compliant parts, and our fully 3D printed electronic-free soft robot that actually can walk just by an input of air. And I'm going to tell you a bit more about why we actually built electronic-free systems, because we want to implement all of these controls into one system. We don't want to have a complex control system, because when we did start with all of these pneumatics things, we really needed check valves, we needed a compressor, we needed a microcontroller to control the motion of our robots. And we thought, okay, that is stupid because nature does it in one pack. And then we thought, okay, how could we translate, for example, the motion of the leg of this little tortoise here? And we thought, why don't we do electronic-free control systems and add pneumatic logics into these? And the robot here can actually do the same movement as the turtle, forward, backward, and downward motion of the legs. And we could then introduce a, for example, trot gait using our electronic-free logics here, which we 3D print fully, and can make not and an OR gate, create not and an OR gates and control circuits with that. So we have we enable with that complex motion without a complex control. And why I'm here today is because we use Průša printers to actually build these, and these were the only very precise systems that we needed to actually build that with a very, very flexible material, the Filaflex A70 here, and that enabled us to make bendable round 1 millimeter channels. And when we put them in between two pneumatic cushions, we actually can squeeze them shut and then not have a signal running through the green tube here, and then we can create ones and zeros and have all analog logic. And as we can 3D print them, here you see one of our logic gates, we can also play a bit with them and see how robust they are. And the cool part is you can actually squeeze them down to 2 millimeters and they can still function afterwards. So through the TPU material that we use here, we have an extremely robust system, and then we can 3D print our robots from that and use them in environments that are quite extreme and they will not break. And when I say 3D print them, if you want to have one of those for your home, you can actually 3D print them in 50 hours, scan the code here, it's on printables, and you can see if you can print these at home and have a little toy with you. But we can do a bit more with these. We can put them under pressure and then we can let them walk around. You can even step on them and then will not break. I have them and I will let that walk again in the workshop later. You can put them actually underwater and they can transport things. They can interact with the environment there. You can even run them over with your car, and that is the one we ran over with the car. You can throw them off a building, so you can really use them in environments that are dangerous to different hard robots, or use them, for example, with these electronic-free controls in environments where electronics would fail, like high radiated or high magnetic things. But you can see it only runs in one direction, and we wanted to use them to be able to interact with an environment. So we needed to answer the question, how can we now sense an obstacle with only using pneumatics and a 3D printed part, for example? We thought, okay, we take a step back, look at our bigger system, because we have here our breadboard robot, where we just can configure different logic gates together and 3D print parts that we need. And we actually added a contact sensor on the front, then added a pattern adjuster on top, have a motion switch. We have a 1-bit storage here, so we have actually memory in the system. And the soft sensor is quite easy. You 3D print the full part. You have in general, you have just a kink tube that is in a PLA setting. And when you push it down, it opens the kink tube. The robot is happy, it knows now, oh, I hit something, and I can walk away again. So with that, we can actually make now autonomous robots that are able to interact with the environment or actually recognize the environment. And on the right side, you're going to see a tethered version of our six-legged robot, and on the left side, you're going to see a untethered version where we have a 16-gram CO2 capsule in there that adds a bit of weight, but also please keep in mind that it's a finite volume, so it will get slower as it gets to the end of our cartridge, but it's quite nice. It can walk into the object, recognize, oh my God, I hit something, and walk away, and with that can orient itself in the environment a bit, and you can see it slows down, and at last it goes to sleep because it's tired. But now you can ask yourself, okay, how can you actually interact with that? And we thought, okay, let us add a gripper here and let that thing walk and recognize an object, grasp an object, so we're in, and then move away with that. And you can say, okay, that looks actually very eerie. It looks a bit of a disgusting insect, but the cool part is you can now integrate that. So the next step is, can we actually make it smaller again, a bit cuter, a bit more accessible, but also acceptable? Because when you think that the public sees that, they say, I don't like that, that looks like a creepy bug. But if you make it smaller again and say, hey, can we make it look like a more natural animal again? We can say, okay, well, why don't we use that? Do that, and we can make advanced circuits now. And what we learned from all of these systems in the past, we added that into our newest robot, the Festo Bionic Turtle Bot. That is the cooperation with the German company Festo, and we made that for their 100-year anniversary booth at the Hannover Messe, and it's now running around Europe in different trade fairs, representing us and Festo together. And here we have not only the shell is made from harder TPU, and all the parts here are 3D printed in the very flexible 78 TPU, and we need roughly, if we would print all of them one after another, around 111 hours to print those. But what we can do with that now, it can actually recognize an object coming towards it, start walking, recognize that it dropped the object, and walk away. And if you do something for a trade fair and you think, hey, cool, my robot normally walks like 100 times and then it fails because delamination or something, that thing actually walked 17,800 times. So that was actually a very cool resilience test for our robots here. And the only thing that needed to be changed were 2 legs and 1 pneumatic logic control circuit because they put too much pressure and then it burst. But when I say that this is printed in one go, that it's not printed in one go, but that's the future. So we want to really use the multi-material printing here to actually be able to accelerate our development and our designs and also our production time. Because now we can say, how can we improve it? And we use, for example, the Průša XL, the multi-material printing here. We can combine very, very different materials. We can have conductive TPU, we can have stiff TPU, we can have very soft TPU, and we can print our newest designs of legs, for example. This is a quite bigger leg system, and we can use various materials. The black one is very soft, the red one is a bit harder, and the last one actually even glows in the dark, which is cool if you think about troubleshooting a system that is normally completely transparent. You want to see if you really can do harder parts, then a glow in the dark is actually quite helpful. But we can also activate that quite easily. And with these systems, we can now improve all of our robots and make them print a lot faster, and we don't have any manual assembly. The big robot actually took around the turtle robot took about 20 minutes to assemble, but the big 6-legged took us around 20 hours to fully assemble. And if we could make that, then with these things, we would shorten production time of around 600 hours for the big one to maybe 50 to 70 hours. And With these also we can really do very new things. This is one of our newest fully integrated systems. So we have a PLA frame with a TPU control unit on top of it. We added the tubes here because we wanted to check different systems. But we then have a connection to the PLA with a TPU part, with a hard TPU, and then we have a softer TPU running through it to being able to make joints, and then we have our robotic leg there that is able to walk. And if you want to see how we printed that, come to our workshop later. And now possible applications for these systems are and will be in the future, for example, search and rescue. If we have a possibility to print them in place at the disaster site, we can say, okay, we can design at the field, print them there, and then just send them out with, for example, trackers or iPhones or something to find victims and bring their communication there. We can use them for pipeline inspection, where we would create sparks, for example, with electronics in there, or space exploration, because these things can actually work in a vacuum if you tweak them. We can do underwater monitoring, because there we have the possibility to interact with very flexible and environments and not harm them. We can use them in radioactive or highly mechanized environments. We actually developed our logic gates to be able to manipulate a gripper inside an MRI machine to do tests inside the MRI with our biological samples. We couldn't make a controller work there, and we didn't want to add very long cables at the time. And we can use them in medical and healthcare to develop more safe systems that interact with humans, for example, in caretaker robots that are using very complex, flexible arms and grippers. And with that, I'm nearly at the end of my talk, and the key takeaways I would say is that we can use biological motions to inspire new soft robots and enable new systems, that our pneumatic logic actually enables us to make more and more complex, fully electronic-free robots, and that multi-material printing is really the next step for soft robotics in that part. And if you want to learn more, come to Pavilion E at 4 o'clock, and you can learn how we 3D print these soft robots and what we can do with our plant-inspired systems. And with that, I would like to thank all of our group. If you ever want to contact me, scan the QR code, and if you want to work with me, I am actually searching for a new job next year. So send a shout out, and I'm very happy to bring that into your company or something. And I would like to let my little buddy say the last words. So if you have any questions, come to my workshop. Thank you. It's been a pleasure. And thank you for Prusa for inviting me here.
Thank you, Fox, for such a great presentation. And for those of you who are interested in what Falk has presented, I remind you that you can get a hands-on afternoon session with him starting at 4 o'clock in the Pavilion E. And speaking of time, we're almost at the end of our morning program. And to wrap things up, I would like to invite to the podium Sherry Lassiter to wrap things up.
Excellent, thank you. Thank you, Stefan. Well, I just want to shout out to Nicole. Nicole is our stage manager. I don't know if you've seen, she does everything from carrying furniture to being sure the audio visual is right to calling the speakers and getting them ready. She even finds lost cell phones and finds drugs in the drugstore for you. So thank you, Nicole. Wow, it's a week. It's a whole week. We're almost done. I'm just like, what? It went too fast. I know we're all exhausted, but still, I could stay another week. Could you? Yeah, absolutely. Well, one of the reasons that Nicole helped me up here tonight is we're here to celebrate really milestones from the network right now. We always like to celebrate the wonderful things that are happening to our community and with our community. And I'll just start with my own milestones. This year was a year of repair for me. So I had my shoulder replaced and my knee replaced this year. And I went to 4 surgeons to try and figure out how to get this done and get it done well. And they were very frustrated with me because I asked all the wrong questions. I was like, what software did you use to design my shoulder? And, what was the machine that you used to, mill my knee, And, did you use high-precision machining, or did you do molding and casting, or 3D printing? And they looked at me like I was from Mars. And then I asked the question, well, will it hurt? And they go, uh-huh. But the answer to those questions was yes, all of the above. So finally, I don't just talk the talk of digital fabrication, I now literally walk the talk of digital fabrication. So that's my personal milestone. But let's celebrate all the others. Thank you. So first we have Remy and Carla. Are you guys here this morning? At any rate, they are engaged. They met at Fab Lab Recife. And she's from Brazil, and he's from France, and now they're living in France, so they'll get married soon. Where are you, did you say? Hey, congratulations. And then we have Noor and Rabia got married on April 11th. Noor is a really good guru in the Fab Lab network. He's an instructor, and we want to congratulate them from Pakistan. Let's say congratulations. Congratulations. Oh, and Ohad, his little baby, Jiva arrived this year, and I think it was March or April, right? And so, welcome to the world, Jiva, everyone. Welcome, right? And Dina, now I don't know if all of you know Dina, but she was the host of the Egypt. She was one of the hosts of the Egypt Fab conference, and she got married last year, and on January 1st, her baby daughter, Alexandria, arrived. So congratulations, and welcome to the world, Alexandria. And then those of you who know Nadia Peak, she's now got a version 2.0. Nadia and Hunter had Pia Olive Peak on May 20th, and so she's a new mom, and I think her 2.0 version is going to be even more exciting. She's now at the University of Washington as a professor. Yeah. And I believe if Sylvia, Brandy, and Martin are here, are they here? Where? Ah! So they welcomed Lotte, okay, to FabLab.at in Austria, just about 3 months ago, right? Congratulations, and welcome to the world, Lotte. And this is from Kerala, India. This is Yadu and Alice Sharon. And Yadu, they had a little baby in March, Nihara. So welcome, Nihara, to the world. Yay! And this next one is a local favorite. So Jan and Marketa from Fab Lab Brno, they had a little Jonas this year in January as well. Welcome, and congratulations. And Thomas Vivanco, where are you? Are you here? I saw him last night. He was really running around being very cold. But at any rate, he ran the Boston Marathon this year. He finished in 3 hours and 2 minutes. And he also won the Best Paper Award for the Fab Research Paper. So congratulations, Tomas, on that milestone, wherever you are. And, Tomas Diaz, Fab City Foundation. He, I don't know if you can tell in this picture in the middle, but he has 2 little girls, and he's got 1 more on the way who's going to be coming in a couple of weeks, possibly, very, very soon. So congratulations to Tomas and Kira. And then we have Sarah Fabito and Zach Hudson. They were engaged on December 24th from the Philippines. Congratulations, you two. And I think that's it. Fab, thank you to all of you. And please, next year, send me well in advance your milestones, because we want to celebrate you and all that you do in this world. So again, thank you, and thank you to this amazing team. And we have this is our last day of real content. Tomorrow is more the festival, but I invite you to take advantage of every second of it, because it'll be a whole year before we see you again. So thank you very much. Thanks.
Thank you very much, Sherry. That was lovely. And looking at the time, we're almost up. And this is the last day, last real day. Tomorrow will be a FAB25 festival. A lot of people will come, and I certainly hope they'll get to experience the atmosphere and the intensity of what we had here, because this has been awesome. This is almost everything for me, and I would like to thank you all on behalf of the entire Prusa team for your support, for your opinions, for your feedback, for just being here, for coming. Thank you for everything. You guys mean a lot to us. Thank you. It's been my great pleasure to be your host today, and the final moment comes near. I would like to invite to the stage the whole FAB25 team, and you can thank them in personal, and they get to pass the torch to the next year. Thank you.
Oh! Hey! Hello everyone, here we are. So, now we have a short session, and I will call it the thank you session. So, we will say many thank yous. I recommend you to start warming up your hands, because you will clap a lot. So, you can start doing that now. So, Tom from Fab Lab Brno introduced both of the teams on behalf of both of the organizers, Make More and Fab Lab Brno in Brno. And now it's me, Jan Dvořáček, the FAB25 program lead, and together with me it's Barbara Lišková, the main project manager from Make More and the main muscles, brain, and everything behind the event in the past month. So please, welcome.
Hello everyone, hello, nice to see you.
So first, thank you. We started working on this event approximately already 5 years ago. It was my first, I started the candidacy, it was my first real job after the university, so I really put a lot of heart and energy into this. And I would like to thank you for coming to the heart of Europe from 55 countries all over the world. In our system, officially I can announce, we have over 1,100 registered participants. They were spread all of the 7 days so far and both of the cities, so really thank you a lot for coming. I think we had a wonderful event. So we started our event in Brno with a keynote by Scott Allen, and that was called Storytelling for Makers. And I would like to tell you a story. But please keep in mind, I finished this presentation 3 a.m. We are both exhausted as hell, so if you want to take a photo of the two most exhausted people in Czech Republic and Prague right now, you can do it.
We are here for you.
Okay, going back in time, June 4, 2020, I secretly took a screenshot of a first call with the FAB Foundation, and I put this slide on because I remember just one sentence from this call, and that was Neil telling us before the pitch, hey, it's important that you make a local impact. And that's what we tried to do, and that's what I will wrap up my little speech with. He also mentioned the hero's journey, and I'm pretty sure we've been through all of that at FAB25, and hopefully we are now close to the return with the gift from the goddess so that everything will be perfect in the end. Let's go 1 month forward. So this is the document that we used to revise the first text for our website for the candidacy. And you can read those now, but this was basically a promise to the community. This was the few bullet points that we put together within the team and the goal of FAB25 5 years ago. Again, going forward, half a year, I don't know if you recognize us at this picture. This was like the first proper team building. We rented a cottage house. It was cold as hell. We got sick after it, all of us. And you can also see we are playing a board game, and actually it was a maker train game, let's say, because we were building trains. So that's pretty funny. And then after this, we started to draw up a basic project plan, and then started to meet basically on a 3-month basis all together. So as you can see, we've been through COVID. Again, I don't know if you recognize us. Yeah, and one of the things that we really told each other, hey, in order to make the program really great, and not just for ourselves, but for the whole world, we need to bring the community on board. So we came up with an idea of 3 pre-events that we organized in the past 3 years. This was the first one in Prague in June 2022. The second one was organized in Brno, April 2023. And the last one, last year, again, back in Prague in 2024. You can see that over the years, I changed my haircuts a few times from going bald to, having long hair again. So let's see what comes after FAB25. Another highlight, this is August last year, Mexico. And we've put this picture because by then we really started to promote the event, and we got a great feedback already in the preparation phase, so that gave us a lot of energy to move forward. This is just a few months ago. This is a photo from the first team building of the bigger team. So we hired more people. You met most of them during the event. Going forward, March 24, 2025, this was the first official meeting of the Association of the Czech Open Workshops. So I'm getting towards the impact now. Another event, because apparently we like to organize events. This was called the Forum of Digital Fabrication and Creation, and that was organized in order to try to bring the Czech stakeholders on board. We invited a lot of officials, and yeah, this is again creating impact on the governmental level. And this is just a few days ago, July 6th, a group photo. Everybody's still smiling. Yeah, so this was my story, and I would like to recap the impact. So we saw it in the storyline. I think Czechia was put on the map as a maker's heart of Europe in these days. We've received an incredible feedback from you guys, and we are really thankful for that. That kept us moving in those hard days. We are having new partnerships that we weren't, even expecting to have, and we made a lot of global connections. We made an European impact also with all the pre-events, and I think there will be a lot of projects upcoming. And I think the future looks bright for Fab Labs in the Czech Republic. You saw the Vida Science Lab. We are having the Fab Festival tomorrow. You saw the biggest makerspace in the Czech Republic is being built. But it will be a lot of work, and the work just starts after the event. So we need to leverage what we've done here over the past few days, and we really need to push it through the media, amongst the stakeholders, and yeah, to build the Fab Lab infrastructure and the maker community more and more. So that was the impact. I hope Neil is happy. We are happy. And now we've prepared a short FAB25 highlights slideshow. I would like to also point out our photographer, Stepan Filip. He made these amazing photos, most of them, and he's been with us the whole event. So let's start the music. So thanks a lot, everyone. I hope you realized that these were the promises that we made to you, and I hope you're happy and all are fulfilled. And now, the thanking part. I will hand the word to Barbara, and she will invite our team on stage.
Hello, everyone. You see from the pictures that the whole week was pretty amazing, and I am so happy to be part of it. I've never expected that it would be so warm, so full of inspiration, so full of smile, and that you're gonna share so much within yourself. So I would like to thank you for that. The applause comes to you.
So first up, Barbara, thank you very much for your dedication to FAB25.
Thank you. Thank you. And as you can see, the event was pretty big, so of course the team was pretty big. But first, I would like to thank our moderator. She was amazing. She led us through the whole week. So I would like to invite on the stage Sonia Baranova. Yeah. And now I would like to thank members of our two companies who work together, two organizations from Fab Lab Brno and Make More. So please come to join us on stage. Tomáš Mejzlík, Daniel Rierotka, Vojtěch Kolařík, Ondřej Kašpárek, Mark Lambert, Eliška Jonášová, Pavel Uhřík a René Savková. And this is only the small portion of our team, actually, because in the backstage there are still people waiting. So now I would like to invite the rest of the team to join us around the stage. Anička Kvítková, Vlaďka Ptáčková, Honza Šušklep, Antonín Gazda, Julča Fejtová, Petra Krákorová, she is on the backstage in the regie, don't know if she can come or not. Míša Kašpárek Mixová, Klára Šimunková, Ila Tandlerová, Pavel Liška a Martin Tesař a Nikol Linke. Thank you so much. You were amazing. Thank you for supporting us, for helping us with workshops, taking care of our speakers, partners, taking care of us. Thank you for taking care of all our attendees. Thank you so much.
I would like to conclude with thanking also Barbara and Jan, because it's been the biggest event we've ever done, and I think in the last days we've received many words of gratitude, and I would like you all to point all the energy to these two guys, because without them we wouldn't have the great program, and without Barbara we wouldn't have this whole event, so thank you so much.
Thank you. Now, we would like to thank our partners. We are not going to name them all, but in general, we would like to thank for them for their financial support, promotional support, technological support, and for the community help and support they did us during the whole event. We also like to thank our local stakeholders, and especially we would like to thank Průša Research that they are here with us, and they are such an amazing support, not only for the FAB25, but also for the whole community. Also, I would like to thank all the people who are actively participated in the program, all for you thank you who did the workshops, who participate on stage, who helped us in any way possible, the ones who gave talks, and you were here with us the whole time and you made the program. So thank you for you.
And now, you know, we had kind of a lot of people, but there was many, many more people. People from more people from Make More, actually. I almost broke my tongue on that.
Yeah, sorry, this was actually my part. It's still blue.
It's okay.
So,
I took over.
yeah.
Then we had a lot of more colleagues from Fab Lab Brno, from Fab Lab 11, and also our amazing volunteers. So look, these are the names. Look how many people is this. So thank you, everybody. I think also in Prague and in Brno, we will have some kind of post-event to celebrate this success. And now, Joe Průša, are you here?
Maybe before we continue, I just want to say a special thanks to special person. The person's dedicated the last 5 years of his life to this event, and I think it's safe to say that he's the most important part of the event and of the spirit of the pre-events and all stuff that is happening here. And please give it up to Jan for making this real.
Thank you, everyone. Now, Joe, come to the stage. So again, thank you, and thanks to Průša Research for making this, helping to happen, and we are really grateful.
It has been an honor. You know, we brought together Maker Faire here. Now this, I am certain that Czechia will be the maker capital of the world. And what is this? This looks suspiciously shaped.
Yeah. And I think we need some more people to get on the stage. So please welcome, and luckily they are at the same time, they are both also the organizers of FAB25 and also the host of the next event, FAB26. So please welcome the Fab Foundation team. Norella, Sherry, Neil, Chelsea, Jean-Michel, Abigail, Rodney, Adriana, and Luciana. Hey! Okay, so let's try to fit. Oh, you got some lobsters with you. Cool. Thanks. Okay.
So, we would like to thank you. I think nothing of this has been possible without their support. We've been here just telling them a couple of things here and there, but I think they have it all under control. And we are so grateful that we met with this incredible team in order to make this happen for you guys.
Okay, now, will you open it?
I did not get the instructions how to do that.
You just pull the bow.
Yeah.
No, we need to do this together.
Yeah. Okay.
Like this.
Yeah.
Oh.
Whoa!
I've heard stories about this one. So, what does it say?
So what is this?
This is Piece Unique 101 Special Core 1 to, I guess, be as a gift for the upcoming year of Fab.
Yeah, great.
Thank you. It has been a great honor to host Fab in Prague, and I cannot wait to come to the next year.
In Boston.
Oh, yeah.
So on behalf of Cambridge, Boston, Massachusetts, New England, United States, and the world, we thank you for this wonderful gift and can't wait to host, although we're kind of depressed because I don't think we can top what you just did. I think you set the standard for one of these events. So we may not reach what you did, but we'll do our best, and we can't wait to host all of you next year at FAB26. Thank you, everyone.
Okay.
Thank you.
So we will leave the stage now just for FAB26 team, and they've prepared something special for you, so we can play it now.
25 years ago, a question sparked a revolution. What happens when anyone, anywhere, can make almost anything? From Boston to more than 150 countries, Fab Labs became a global movement, empowering communities, reimagining education, and reshaping how we live, learn, and work. Now, it's time to ask, what's next? For people, for the planet, for the tools we use to build our future. In 2026, we return to where it all started, to celebrate 25 years of digital fabrication impact in our communities, and to imagine the next 25. Join us for FAB26 Boston at MIT and Fab Hub Kendall, a global gathering of fabbers, makers, educators, academics, tech innovators, industry leaders, and change makers. FAB26 is more than a conference. It's where the future is made.
Woo!
We should do just a 360. We should just rotate. Just everybody rotate.
Okay, so
We're just gonna rotate.
rotate where?
Clockwise.
Clockwise, that way.
Slowly.
No, slowly,
Yeah,
slowly.
slow-
Okay.
Just to see everybody.
Okay, good. Okay. A slow hello for the whole auditorium. Woo! So as you can see, we couldn't get ourselves into a one single costume, and we decided to represent Boston in the best way we could. So yeah, it's basically FAB26 next year. We're celebrating the 25th anniversary of Fab Labs next year. We're going back to Boston, as Sherry nicely portrayed it in our video. And so we want you to save the date. We want you to start now the process of actually getting in. So right now, you can access our website. You can join the WhatsApp group. We already have a WhatsApp group. So if you are interested in joining next year, just that will be our main communication channel for now, as well as more information will be posted on our website. And we know that traveling is a little bit not so great this time of the year. Not this time of the year. And so we want you to start the process now. We also know that the World Cup is happening next year as well, just before us, so it's gonna get crowded. So if you start now, probably the process will be a little bit slower. We will be able to support you in some ways. So just reach out to us, fabevents@fabfoundation.org, and we will be able to provide you with more information. So I think without further ado, we have our mascots here, our lobsters. Yeah. Woo for our lobsters. And see you in Boston next year. Woo! What photo? Okay, and just wait. We have a couple of announcements just before you go. This is not over.
I will be your host for the last 15 seconds. So, please everyone enjoy the rest of the Průša day. It's packed with amazing content. I will myself try to join in the afternoon. Also join us for the Průša party and try to find the FAB25 team and have a beer with them. One more announcement. We will try to make a group FAB25 photo, so everybody is invited. 6:15 at the big fountain in between the pavilions. So just when you end the workshops, please try to go there. We will also post this to Eventy so you don't forget. Who arrives will be there on the photo. So yeah, that's all from the big stage from FAB25. Thanks a lot. And now you can go and pick your lunches. And I would like to ask the FAB25 team to stay here and to come here to take a group photo, but just the FAB25 team. Thanks a lot. See you.